started. Okay, so with that, just last one check. Am I still audible? Okay, good. Okay, so what we are learning today, and just confirm, is my screen is visible on the Excalibur? Okay. And those who do not know me, so my name is Bhuvnesh Arya. So I also run this website inside Veda, where I capture my lessons on system design and software architecture. So if you guys ever get a time, just go through it. It's a website which I'm planning to do it so that I can actually give this learning back to the audience about the architecture world, how we will build the system design. But today our focus is on the AI side. And what we are going to look, so let's see out here. So whenever you heard about this term, right, GPT, and you heard about this term, okay, is it not visible? Oh, okay. Oh, sorry, maybe I forgot to share it. Let me share my screen. Share screen. Do let me know if it is visible. Okay, good. So I was talking about my website, which is Insight Veda. So I just document all the software architecture lesson and system design. Whenever you get a time, you go and have a look. And this is the YouTube channel AI Tech Veda, where I'm going to upload these videos which I'm recording, and some of the videos which maybe I'll not do it on Discord, but I'll just document it as a learning. But okay, so today coming back to this topic about the GPT and transformer. Okay, so what we are looking at, and we have heard this term multiple times, right? So we have heard about GPT, we have heard about transformer, we also heard about LLMs, right? So these are the so many terms that are going around us, and we wanted to understand the fundamentals behind that, right? So before learning any technology, you should be aware, okay, what are the fundamentals behind it and how you can learn about it. So let's take a very simple example. For now, let's assume GPT or a transformer is a black box for us. Okay, we do not know what is inside to it. But whenever we give a prompt to it or a input to it like, hello, how are you? If this I give it, usually I am expecting a output. Okay, first word could be I. Okay, and when again the GPT is there, the same magical black box, and here again if I take this input back, so the input is hello, how are you? Okay. And then I'm appending the output of this back to it. Suppose if I add I to it, so then what I am expecting, our next word could be M. Okay, so in this journey, whatever is happening, and again this cycle repeats, right? You again have a GPT, this word will come here, this word will again go back to as an input, and then you will predict a next word as a fine. So if you see in general, what we are doing nothing, we are just predicting our next word. Okay, now technically we call it like a token, but for simplicity, just for now, just consider token equals to word, which is not true. But just for the simplicity, you can assume it for now, token equal to word. But all the LLM models, they usually work in terms of token only. They do not understand the words. And how these tokens will get fit into that, we will also look into this. So this is how a GPT runs, and whatever be the magical thing that you see, okay, you give a bigger prompt to it, maybe do this, do that and all, and it will give you a big paragraph, right? And but you need to understand two things here. At one time, it can only generate a one single token. It is not going to give you a big paragraph out there. And second, whenever it generates a predict token or next token, it will again feed it back to the input and it will generate a next token. So this is how our GPT works. But here some of the question comes up. Okay, so before we jump into what is GPT and all, first understand what is around the history of it. Okay, so in the history, we have some language models. Okay, so first understand what is language models. So language models means that suppose anything which is related to your text or a language, any model that is trained on top of that to do this. So like a language translation. Suppose if you want to translate something from English to Hindi, okay. So for that you require a language model, and these are initially introduced by the Google in their Google Translator. So where you can convert from English to Spanish also, any language, right? And these are called as your language model. And two famous language model that we had before to the transformer is the RNNs and LSTNs. Okay, so I'm not going too detail into this, what are these models and all, but we need to understand one thing first. These are the neural networks which are helping you in getting the uh, translation back, or maybe the natural language. They are able to predict the next token. Again, everything is there. But only thing that you need to understand is that these are not these are not putting the information in a parallel format. So these are sequential models. So again, do not worry what do we mean by sequentials and all, but just understand these are sequential models. And second, they do not have a big memory. So they were having a short memory. Okay, so these are the two things that you need to remember about these models. And later on, what happened in 2017? So Google introduced one paper, that is attention all you need, where they introduce this new model which is a transformer model, and there we call it like a transformer model family, and this is also a language model. The only difference is that these models are trained on a large data set, and that's why they start calling it like a large language models. Okay, so the only difference is that earlier also they were using the language model, but those were used actually mainly in the use case like spam classification, ham classification, and if you want to do any kind of a fraud detection, and if you want to do simple kind of a language translation. So there actually these all were there, and you were able to understand all these things, whatever we have out there. But once these large language models come into the picture, so their whole thing is about the large, because these are actually trained on a large chunk of a data. So they are trained on the Wikipedia, they are trained on the books. So whatever you see on the online, these models are trained on those all those information, and that's why they call it as a large language model, because they have a more capacity what they can do. We'll come to that, what all those main capacity, how they are different and all. But just understand, I'm just trying to give you a little bit perspective about the history, how it is getting evolved, and why we are learning about this. And now then in transformer family, the two models that got very popular, one is your GPT and second is your BERT. Okay, so these models are actually means a family belonging to the transformer, and this is the most popular one that got popular with the help of chat GPT. If you heard about the chat GPT, this is the first model that came into the existing by OpenAI, which is a company, and which is actually trained on this model, which is GPT. Now if you see GPT, it is also what is it is reflecting. So T stand for transformer, P is like predictive, so you need to predict a next token, right? So that's why it is predictive in nature. And then G is generative, and this is also called as a pre-trained. So I think predictive, I may not use it here. I will use it like a generative, and the pre-trained is the word which talks about, okay, this is actually trained on a large data set, and generative in nature because it is able to predict the next token which is generated, and transformer as it belongs to the transformer family, and that's why it is known as the this. So this name is taken by ChatGPT only, but all other models that you see, maybe it's a Gemini, maybe it's Claude, any model that you see available today, whether it's open source or whether it's not open source, all those are belongings to the GPT family. But is it still used? But it's still used by the Google only, which internally used in their again language translation, the Gmail and some of the application. But majorly what you see in the public domain is the GPT models only, which are actually used for creating the Gen AI application, which we, me and you guys are working on. This is what we are looking towards. Okay, any question on the history side? I just wanted to be little interactive. So if you guys have any question, just you can keep asking in between. Otherwise, I'll go with my flow. Can I go ahead? Just taking a confirmation on the server. Am I still audible? Hello? Okay, thank you. Okay, so if I look into this, now what we are looking into that is the transformer architecture. So if you see transformer architecture, this is the paper that you should all read about. Attention is all you need. And this is what we are looking into this transformer architecture. And it has a two component. If you see on the left, this is what is a one component, and if you see what we are seeing on the right, it's a different component. So first we call it like a encoder and second is a decoder. Again, a little bit of technical, but do not need to remember everything right now. But first, let's start understanding few things. Okay, so what do we mean by embedding? What is the encoding, right? What is the multi-head attention? We try to break all these things and then we will try to understand what is this whole architecture all about. So let me again go back to here. When I said that GPT is there and I put it the word like hello, how are you? And it is giving me a word like I am fine. So in this case, what is happening? First, computers do not understand the text. Okay, so computer will not understand hello. Okay, so how they are able to understand I am feeding a statement like hello, how are you? Okay, and this is very crucial because computer only talks in terms of number and that is also binary. And then they also, we need to represent this text into some number. A number could be, you can imagine like 1, 2, 3, 4, and then you need to convert into some mathematical representation. Okay. And this part, whatever is there, this we call it like a tokenization method. So when we are looking for tokenization, what do we mean by it? So suppose, as I told that word is not equal to token. So suppose you have a word like playing. Okay. And if you want to break this playing into two, so this is play and ing. So usually this is your first token and this is your second token. And there is no standard rule how many tokens can be come out of this particular word. But I'm just referring here is like if you have this single word, whatever you are seeing on the left is your token 1 and this is your token 2. So this is a simple, and this all depends upon the vocabulary, this all depends upon your LLM, depend upon, and every LLM will have their own size of the vocabulary, own size of the tokenization method. But here if you see, if you have a play and ing, you get your token. And suppose if I give some random number to this play. So suppose if I give 1, 2, 3, 4 a number to this play, and if I give 5, 7, 8 to this, and this we usually call it like a token ID. Okay, so what we mean by token ID is like we are assigning some number to this token, and 1, 2, 3, 4 is there and 5, 7, 8 there, and these are assigned as a token to these values. Now, how we are getting this number and all, again, it depends upon the vocabulary. We will see it little later. But for you, just understand there is one word which is a one number which is assigned to this word, and this is actually get stored in your vocabulary. So whenever in your text you get a play word, you will always see this number attached to the play. So suppose you have a play matrix and play is attached to the 1, 2, 3, 4. And if you have a ing, it is assigned to the 5, 7, 8. So any word where you will have again this walking. So take an example. I have a word like walking. So again, this can be split into walk and ing. But if you see ing will again get this token number same only, which is a 578, but walk may get a different token. So which could be maybe 2, 3, 4, 4. So depending upon these values, this could be different. So if you have this 578 number already assigned as a ing to this, what will happen the next is like you need to understand how I give this number back to the computers. So first step was to generate the token ID, and then the next step is to generate a vector out of this token. Now, how do we get the vectors out of it? And that this process is known as a vector embedding. Okay. So what is happening here? Again, I am repeating. First, we get a word, then word is breaking into token, then token is break into token ID, and then token ID is assigned a vector. Okay. So now how we are representing this vector, we need to understand there is one thing which is known as a dimensions. So what do we mean by dimension? So we need to understand this part. What is happening here? Let's take an example of any word which may be a king. Okay, so king is one word, or you can say like a one token that we are looking into. And let's understand what kind of a dimension a king hold. So suppose if you have a dimension like a authority, or if you have a dimension like a event, if you have dimension like has tail, if you have a dimension like rich, and if you have a dimension like a gender. So suppose if I have these kind of a dimensions. So in that case, suppose these are my columns, and if I have a rows name like king. So king, let's assume I give king has a good authority. So I am taking whatever is a positive number is 1 and which has a low probability or does not have it, maybe you can consider it like a 0. So king has an authority of 0.90. Is this an event? Not exactly, right? Because king is not an event. King is a person who is having it. So maybe I am giving a low probability over here. Does king has a tail? No, it does not have a tail. So then in that case, this becomes like a 0, 0. Is king rich? Yes, there is a very like probability of having it rich. So I'm considering it like zero point 0.5. And what is a gender, right? So king has a gender, and that's why I'm assigning it as a 100. So one, you can consider it for a male. Female, you can consider it like a -1. Now take an example. If I have a word like a queen. So queen, maybe authority little less than a king, but is still comparable. Event, again, this is not an event. Again, I am assigning a lower value. Has tail? No, it does not have a tail. The, is queen rich? Yes, she is also rich, but maybe little lesser than king. And then on the gender side, I am giving this as a -1 because then I'm representing female as a -1. Now again, we have a man. Now man, maybe you can consider it like a 0.60 because this is a normal man. This is not a king. So the man does not have this much of authority. Event, In that case, it is 0.10. Does it has a tail? Yes, it has a tail. Sorry, it does not have a tail. And then it is also not a rich because this is a normal person that we are talking about, but gender wise, this is also a. And then we have a woman. Woman, we can again do the minus of like maybe a 0.05, 0.00, 0.15, and then again minus 1. So if you see in all this, we try to create a dimension of 5, right? So usually in practical scenario, these dimensions are in thousands, maybe 10,000. Usually GPT-4 model, I guess they use is around 12,000 dimension. So these are very big. But just for the simplicity, we are only thinking about 5 dimension only. So one is authority, event has tail, rich and gender, so that we can easily understand. And then we have a king, queen, man, and woman. So if I want to represent this in the form of the vector, so what will happen? Suppose if I want to represent king as a vector. So in that case, whatever be the dimension that we have, I need to represent it. So first is 0.90, 0.20, 0.00, 0.95, and 1.00. So this is my first vector that I created for the king. And similarly, we can create a next vector for the queen, which is a 0.88, 0.18, 0.00, zero, 0.90, and minus 1.0. And similarly, we can create this for a man also, and we can create this for a woman also. Now, if you see, this is how we are storing this information into the database, and which are primarily stored into the spatial database known as a vector database that also understand the vector, and those actually able to do some kind of a computation on top of vector also. But here, if you see one interesting thing, technically, if I say king minus men and plus woman, if I do this math, okay, let me show you also. Suppose take an example. I'm taking only an example of authority. So men has a 0.60 and then woman has a 0.55. So suppose if I do this math for the first authority, so what I am getting 0.90 minus 0.88 plus 0.55. If I do this math, my resultant vector is equals to, or the value is equals to 0.85. Okay. Whereas you see what we have for the queen, the authority, which is similar close to 0.88. Do this for all the dimension like 0.20, zero, 0.8 and all this. What you will get in the resultant is like the vector that you get out of it is very similar to the queen vector. So this is actually how the math works out here, because these are the dimensions that we have created. So whenever we are, so this is like a property, right? If I am removing a man from a king and if I'm adding a property of woman to the king, it is a very likely to be probable, right? This is very comparable to the queen, and this is how computer understand it. Based on these vector, based on these dimension and property, they will understand, okay, uh, this is very near to the. So suppose if I try to plot this into a 2D dimension, again, as I said that these are multiple dimension, not 2D. So suppose if I represent king somewhere here and queen somewhere here, okay, and if I represent man somewhere here and woman somewhere here, so then it is likely that the distance that is there from the king to the queen and the distance that is there from men to the woman, it is going to be the same. And that is how uh, these LLMs are able to predict a next model also. They will understand the context. They will also understand what it is referred within which domain, and they also understand the distance also. So that is how it is able to create, and we usually call this as a Euclidean distance. Okay, this is there. Any question on this side? Actually, these sessions are recorded. So you will find the recording also later on the YouTube channel AI Tech Veda. But for your quick reference, I can say that what we are learning out here is like first we little bit talk about the history of this LLM, right? How they started, what are the language model, then we have RNN LSTMs, then 2017 transformer come, then we have a GPT bird, and then Gen AI apps are there. GPT, mainly what we are doing, we have an input string, we are getting the output thing, but these output is not come in the one single shot. It is always like predicting a one token or one word at a time. Then we also understand word is not equal to token. So we break word into a token. We have a method name as tokenization. So suppose playing word is there, we break this into play and ing. We have two different token, and again we assign some token ID to it coming from the vocabulary. And then once these numbers are there, I'm explaining this table how this token ID is converting into a vector. And there I take a reference of this dimension and a king as a one example, and we have a four vectors that are represented. Once I showed this dimension into 5, in practical, these are 10,000 of dimensions for every LLM model. And then I showed like how we can do the math. This is actually the math that is done by the computers. And this is based on this only, they will be able to predict a next token. At least they will understand if a man has a property, maybe a distance going to the woman, and if I give a name like a king, then then there is a probability to go to the woman by calculating the same distance. Okay. If this is clear, I just wanted to show you two good website which you can actually use it. So one is this tick tokenizer. You can just Google it. So this actually helps you in understand how we are getting, how many tokens that we are getting, and what is the token ID that got generated for it. Suppose if I write like, hey, how are you? And I put a word like I am fine. If you see, this is happening in real time, and this is the model you can also select. So I'm selecting GPT-4o. So this talks about I have a 25 token count here. Okay. And this is also showing, okay, for system, what is my token ID number here? So suppose if I hey, what is the token ID number generated out here? And then again, how is there, R is there, U is there. So this is actually practically telling you if you have this model, what is the chances like if you give this text, what how much token, and every LLM model has a limit to their input token and output token. That's why you need to understand it briefly. And then once this token IDs are generated, these are actually converted into the vectors. And as I said that I only showed you into a 2D figure, right? But this is not the case. Usually in GPT, these are in 10,000 of the. So there we have a different website known as embedding projector. You can also Google this. This is actually talking about a points that are having a 10,000 points and the dimension is 200. Still it is 200 only, but think about the GPT model where the dimension are also like 12,000, close to that, right? So if you see, this is how they are trying to project it, and if you try to go deep into any of the word, this is how they, from the vocabulary, whatever be the word that they have, they are trying to plot it somewhere into this plane, right? The way I showed you for the 2D thing, like king is placed here, a queen is placed here, man is placed here, and woman is placed here. Same way, if you see, they have these many words which are actually showing you, okay, where is pairs come in, and this is actually a good way of just doing the visualization. But as a human, we cannot understand all these dimension. We can only see max to the 3D dimension only, right? But these are much more dimension, but still this is just giving you a good picture around how we can at least see how these particular keywords are mapped into these domains, sorry, in planes. Okay. Any doubt till this time? All good. Okay. Now, what we have learned till now, if you see this, This vector, as I showed you, suppose king has this vector. Again, for a toy example, I'm taking it as a 5 dimension, but usually these dimensions are very large, right? So these may be 10,000 or depending upon the model. This is still what we call as a static embedding. Or some call it like a static word embedding, some call it like a static vector embedding. Everything is same. So in the end, we are just converting word or a text into a number. But these are still a static word embedding. So what does it mean by this? Suppose take an example. You have an example like dog, chase, cat. Okay. And second example that you have is like cat, chase, dog. Okay. In this case, if you see dog is present both side, cat is also present both side, and chase is also present both side. So from a human, we are able to understand these are not a true statement, right? Sorry, these are not identical statement. In one case, dog is chasing the cat. In second case, cat is chasing the dog. So if you understand from this perspective, your context is very much matter, right? So if you are able to understand what is the my context, in what context I am talking about, your meaning will change of that word, right? But suppose if I generate a same vector for both these statement, right? So then computer will not be able to understand. So that's why static embeddings are not uh, enough. We need to generate the contextual embedding to store into our database, to store into our backend, so that our computer also understand what is my context. And then positional encoding will also come, that I'll also talk about later. But let's take some more example. Take an example: the train run on the track. Okay, so if you see this track, this is what we are talking about, a rail track. Like you have a rail track like this, so this is what we is talking about, the rail track. Now if I say my package is late, help me track it. Okay. Now if you see, this is also a track word only, but this track is mainly talking about the tracking of my parcel, right? Because it is getting delayed. This package is late. So that's why I need a help in tracking it. So this is more about tracking the geolocation of this package. So from this context, only vector embedding of a static is not enough. Suppose if I give a track, take this example, if I give this track a vector like 1 comma 2 comma 3, and if I give this track also same vector embedding, so then this is not enough. Our computer will not be able to understand are these both having the same meaning or not. But suppose what I can do, I can do some plus plus to it. I'll tell you what are these plus plus and all, but let's take an example. I'm doing some plus plus to it, which is adding some context to this information, right? And then I'm storing this resultant, whatever is coming out here. Maybe you can consider like this is also a dot dot dot. This is also a dot dot dot, which is the addition of this. And then I'll go and store this information. Then there is a chances like whatever be the resultant vector comes up, maybe it can come like 5, 4, 6, or it can come like 7, 9, 10, right? So there is a chance because we are adding something else to it which is not matching in these two statements. And then we need to understand how we can add some more contextual information or contextual vector to our original vector so that our resultant vector will look different and it will also understand these vector has a different meaning than the actual vector that we have on the first statement. Is this clear? Okay, I'll give you one more example with a simple one. Suppose I say that I made a rice dish called. Okay. So if I have this example, if I just give this like called X, now X could be anything. So suppose if I'm giving just this example like I made a rice dish called, then the example could be biryani. Okay, this could be. But suppose if I give a one more statement, I made a cheese dish called. Now here if you see, I'm actually changing the context of this information, right? Earlier it was a rice and now I am adding a cheese to it, which is again, but my sentence remains same, right? So in that case, your your output could be paneer, right? Because you are adding a cheese dish. So just because you have a different context, first one you have a rice and then second one you have a cheese, then your output is changing. So what does it mean? Like suppose in terms of vector, if I add rice plus dish, roughly maybe it is resulting me into the biryani. But suppose if I add a cheese plus dish, it might be resultant into the paneer. Okay, so what we are doing, we are just focusing on the day, and then we again add some more context also. We add made also, we add made also here. But again, I'm not talking about all these things because these are common. I'm only talking about the difference thing. And there is one more critical factor that comes into this, which I also talk about, which is the attention. But here you just understand what is important thing is like rice and the cheese. And the second thing also you need to understand, if you have these two important statement, only this is having a bigger influence on the output, right? Suppose if I changing from rice to cheese, this is actually converting from a biryani to paneer. But suppose if I rather than made, I say that okay, I ate a, and then I keep it like a rice dish only. Then there is a possibility, then front one can also give me a biryani and second one output could also be a biryani. Because if you see, I'm making a changes from made to ate, but our context is not changing much because here, first way we are only talking about the preparation. In second, we are talking about okay, I consume that dish, right? So if you see, every word or every word have a different impact on the output, and that's what we call it like a probability also. And then there are some technical term like a weightage and all, we'll see it later. But think about it, it is not always possible, sorry, it is not always like you change one word into the sentence and your output will change, right? You need to see which word has a more weightage, and from that weightage, okay, whether it is capable of changing the output or not. And then if you also changing some word, suppose okay, I'll put it like made only, but I can change like from I to V, right? In that case also, if you see, we made a rice dish called, still it can be biryani, right? Because here we are talking about plural. So maybe a group of friends start cooking it, and then also our output is biryani only. So what I'm trying to tell you, it is not only about just a word of change, it is more about the context which is actually changing the output plus, and this is how we understand the weightage. So let's assume maybe I can say that rice or cheese has a 90% weightage to the dish, but maybe made or a, these may be having a 10% weightage, or maybe I or V, this can only have a 5% weightage. So if you have these kind of a weightage or understanding, we can understand that okay, whatever is having a higher weightage, this has a bigger chance of changing my output also. But if the weightage is come and still your context is different, your language is different, then also your output can still be the same. Is it clear with this way? Yes, no. Shall I continue? Okay, okay. Okay, so what I was explaining, like, apart from word, we need to also look into the weightage. Okay, and if you see at the weightage, the rice or cheese, this word has a weightage maybe of 90%. I'm giving any random number, but it is explaining is like if this word will change, maybe it has an impact on the output itself, right? It is changing the dish itself. But suppose if we have a I and a V, I and V maybe have a weightage of 5% only. So in that case, even if you use I or V, maybe your output may remain same because it has a lesser weightage on this. Or made or eight, maybe they have a 10% of weightage. So what I am trying to convey here, the message is like, it is not always about the change in the word that you have. You need to also look at the weightage or that it added back to the context, because every word has some weightage, but every weightage is not um, making that impact to the output dish, right, or output of that. And that is how when we look into this word like attention, all you need, this is what they are calling like attention. We'll see it later, but I'm just giving you some reference. Weightage is also one thing that you need to see into. Is it clear now? Okay, so let's take one more example and I try to plot it also. Take an example like I made a sweet Indian rice dish. Okay, so usually the output could be kheer out here. Okay, so but now understand what is happening out here. So maybe you have a dish somewhere out here. This is your first dish, and then you are actually adding some riceness to it. Just take a property like you have a riceness to it. So what it become like a rice dish. Okay. Then what you are doing? Think about you add some Indianness to it because you have a word like Indian. Okay. Indianness to it. So this become like Indian rice dish. Okay. So this is here. And then one more word is there which is a sweet. So suppose if it is going into this quadrant and then you have a sweetness added to it. Okay. And then you are getting the last keyword as a sweet Indian rice dish. So this is how your dimensions are getting added or your context are getting added because these are your contextual information for this dish. So your dish is a starting point and then you are adding a rice. Suppose if sweet is not there, okay, and it is only a Indian rice dish, maybe it could be a khichdi, right? Or it could be a plain rice. It could be a white rice, or suppose if you or it could be biryani also, but the moment we add a sweet to it, right, so then it can no longer be a biryani. So then it could be either a kheer or maybe some maybe sweet white rice depending upon whatever is there. But this sweet, if you see, this has a bigger weightage on this because this is actually changing a dish directly maybe from a biryani to kheer, right? So that's why you see from a weightage perspective, sweet has a more weightage. Then uh, rice is also having a more weightage. Then Indian is also having a more weightage. Suppose rather than Indian, I'll say Italian or maybe I'll say Arabian, right? So depending upon these different continent or different countries, maybe they are cooking a different kind of a rice, which are not so popular into this India, right? So what we are doing actually, as I told earlier, suppose if you take an example, dish has some vector. So it has vector like zero point 0.9, then it has 0.72, then it has 0.66, and then dot dot it is zero point 0.8. So if this is my dimension of the dish, then if I add a riceness to it, so what do we mean by riceness? Suppose this is the vector that I am talking about, the riceness. Maybe it is also having some value, so like 0.43, maybe 0.91, 0.18, and then dot dot 0.75. And then again we have a next word which is a Indianness. And then again you have a similar vector out here, a bigger vector. And then the last, if it is there, it's the sweetness, right? That is also a vector is there. This is your sweetness. So you have this vector. Again, you have dot, 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 all these words. If you add all these vectors, suppose if I'm adding these vector, if I'm adding these vectors plus to this, and if I'm adding this vector also, the resultant vector may look like a kheer, which is very comparable to the kheer. And then you can have a resultant vector like 0.34, 7.5, 0.38, and depending upon minus 1.16. So this is what we are talking about, the contextual information. If you see single line, what we call it like a static embedding, right? Because this is a word which is get it embedded with a vector. But the moment you start adding a context to it, so this is one context, this is another context, this is another context, and then the moment you add this whole call it like a contextual embedding. This is no longer a static embedding. And this is what we actually use in actual LLM model. We do not use a static embedding. This is the contextual embedding that we store into our database or maybe into our LLM model for trainings and everything. And this is how your even your same word like track can have a two different meaning depends upon the context, and they both can have a different vector stored into your database. But in this case, it is coming closer to the key, and so that our next predicted token in this could be a key from there. Is this clear? Yes. So if you see earlier, again I'll go back to this king, queen, man and woman example. I try to plot this, right? So what we are doing, if we have the vector and if we do the summation of those vector, see, first you need to understand LLMs are not going to be definite output, right? They only talk on the probability, right? They never know what is going to be the exact model, exact next token. And then they go into the feedback loop. They try to understand from you also whether this is the right output or not, right? And then again, whatever is there, you can say that, okay, yes, this is the correct output, not correct output, and then again go back to the feedback loop that is actually used in the model training, right? And but what they are actually trying to do, they are coming as closer as to your desired output, but they never guarantee like they can give you a 100% result, and that's why they only talk in terms of probability. So if you see here, based on this dash riceness and all, maybe this vector is going closer to the kheer vector, right? Wherever the kheer is there, and there actually it is going by adding this, and the resultant is coming closer to the kheer. But it could be something else also, right? The moment suppose you remove Indian and you add a Arabian to it, right? So suppose if you have a Arabian out here and then you add a sweetness to it, so maybe it is going somewhere else. So this could be some other vector. I am not sure about any, but it could be Arabian rice dish, which is sweet in nature, depending upon that. But the point is that we only static embedding are not enough. You need to add a context to it so that it can go up to the desired output. Is it clear? Okay. Uh, Now I have another things to cover, but it's already 1 hour past, although we have started little late. Do you guys need to continue or can we go for another session? I would say another session might be better. But if you guys are okay, I can continue a bit more. Okay, that's fine. Okay, so I'll take few more questions if there are any. Otherwise, we'll continue for another session. I'll inform it. So be a part of that insight with the Discord group. So depend, I'm not very consistent with my timeline, but I'll try to cover up within a week or something. I'll I'll inform there on the group. But this recording, I'll try to keep it on the YouTube channel because some of the folks are not able to join it, so they can refer it later. And if you have any question, maybe you can ask in the next session. If you are not able to join it live, maybe again you can go through the recording because I'm going to record next session also. But the intention of this group, this whole channel is just to clear some of the fundamentals that are evolving around. And I keep taking say these kind of basic sessions, which are very basic. I'm not going to talk anything about the hype, the models and all, but this is all about what is going behind the scenes so that whatever you are learning outside of this, at least your fundamental remain is strong. I do not want to do that. See, it is easy to do that, but the point is that this will actually this will actually derail our whole learning journey because if I start talking about okay positional encoding, if I talk about multi-head attention, right? There is no point of giving those words or meaning to it unless you will not understand what is happening in the background. So my objective is that first I'll try to uncover all these nuances. What is like token, what is vector, what is static embedding, what is contextual embedding, what is positional encoding, right? What is attention, what is multi-head attention. Once you understand all these components, I can tell you the transformer architecture is only a 15-minute job. So that is not going to take a lot more time. Okay, anything else? If no, we can wind up. Thanks for joining. See you in next session. Bye bye.